This video focuses on the two-sample z-test. So far, we have looked at hypotheses involving one proportion. The two-sample z-test is used to compare two proportions. For example, we might want to study both men and women to determine if there is a difference in the proportion who exercise regularly. We now have two population proportions, and the variable of interest is the difference between them. There are four assumptions for the two-sample z-test. The first is random or fair sampling. The second is independent samples. Subjects cannot be in both groups. The next assumption is that observations within each sample are statistically independent. Knowing whether one individual exercises regularly must not provide any information as to whether another does. And there must be only one observation for each subject. The last assumption is sufficient sample size. The rule of 5 applies to both samples. These are critical assumptions. If they are not met, the test cannot be used. Random sampling is not always possible, so we meet the assumption by drawing samples that represent as much as possible the populations to which we are generalizing. A study compared the effectiveness of two smoking cessation programs on smoking cessation rates. 24% of volunteers in Program A and 30% of the volunteers in Program B had stopped smoking and remained non-smokers 6 months after the interventions. These were samples of convenience. We want to know if there is a difference in the effectiveness of these two programs. We'll use the standard significance level of 0.05. Here is a summary of the data. I'll call Program A Group 1 and Program B Group 2. The researchers would generalize their results to a theoretical population of smokers who would volunteer for such programs. And the parameter of interest is the difference in the population proportions who are still not smoking after 6 months. We do not have random sampling, so the ability to generalize is limited to those who might volunteer to participate in smoking cessation programs. All subjects are either in Program A or Program B, so the samples are statistically independent. To meet the independent observations assumption, each subject must be measured only once. Because sampling wasn't random, the researchers must also ensure that other family members or friends are excluded from the study, because they might influence each other's probability of quitting. We have the data, so we can check the sample size assumption, which has been met. The null hypothesis is that there is no difference in smoking cessation rates between the two programs, and the research hypothesis is that there is a difference. Unlike the one-sample z-test, no specific population values are stated in a two-sample z-test. The model of the null hypothesis is all possible values for p-1 minus p-2 when the null hypothesis is true. We are using the normal distribution because the sample size is large. Here's the standardized model with the rejection region marked. The research hypothesis is non-directional, so this is a two-tailed test. The mean of the distribution becomes 0 when we standardize the distribution, and the critical values of the test statistic are plus and minus 1.96. This is the first table produced by SPSS, showing the results for each group. The next table shows the z-test results. The numerator of the test statistic is p-1 minus p-2, and the denominator is the standard error. The p-value is large, so we do not reject the null hypothesis. We conclude that there is no statistically significant difference in the effectiveness of these programs based on 6-month cessation rates of volunteers. The test results include values for n for both samples. The two-sample z-test is used to test hypotheses about two population proportions. In addition to the assumptions for the one-sample z-test, this test requires that the two samples be statistically independent.